సార్ స్టార్ట్ చేయనా? హలో
సార్ ఓకే సార్ వినిపిస్తుంది.
గుడ్ ఆఫ్టర్నూన్ మేడం. గుడ్ ఆఫ్టర్నూన్ ఎవ్రీబడి. ఈరోజు మన ఎస్ఆర్ అండ్ బీజీఎన్ఆర్ గవర్నమెంట్ ఆర్ట్స్ అండ్ సైన్స్ కళాశాల అటానమస్ ఖమ్మం సైన్స్ అసోసియేషన్ ఆధ్వర్యంలో వన్ డే నేషనల్ సైన్స్ వెబినార్ని నిర్వహించుకోవడానికి ఈ యొక్క సెషన్ని ప్రారంభించాము. ఈనాటి ఈ యొక్క సెషన్కి మన కళాశాల ప్రిన్సిపల్ ఇన్ఛార్జ్ ప్రిన్సిపల్ అయినటువంటి శ్రీ టి జీవన్ కుమార్ గారిని అధ్యక్షత వహించవలసిందిగా రిక్వెస్ట్ చేస్తున్నాను. సార్ ప్లీజ్.
Thank you, sir. Thank you very much.
Come on to the chair, sir. Welcome, sir. Welcome, sir. ఈ రోజు ఈ వెబినార్ యొక్క ఉద్దేశము మీకు అందరికీ తెలిసిందే. సైన్స్ అండ్ టెక్నాలజీ ఇన్ ఇండియన్ స్ట్రాటజిక్ సెక్టార్స్, కెరీర్ ప్రాస్పెక్ట్స్ ఫర్ సైన్స్ స్టూడెంట్స్ అనేటువంటి అంశంతో మీ ముందుకు వస్తున్నాం. మరి ఈరోజు ఈ మన కార్యక్రమంలో విచ్చేసి పాల్గొన్నటువంటి గౌరవ లెక్చరర్స్ అందరికీ మరియు విద్యార్థులకు ఈనాటి కార్యక్రమానికి ముఖ్య స్పీకర్గా విచ్చేసినటువంటి డాక్టర్ మల్లు వెంకటరెడ్డి గారికి స్వాగతం పలుకుతూ మరి ఈనాటి కార్యక్రమాన్ని ఉద్దేశించి మరి కొన్ని మాటలు మీ ముందుంచదలుచుకున్నాను. సైన్స్ డే అనేటువంటిది ఎందుకోసం నిర్వహిస్తాం, వాట్ ఈస్ ద ఇంపార్టెన్స్ ఆఫ్ సైన్స్ డే అనేటువంటి దాన్ని చూసినట్లయితే శ్రీ చంద్రశేఖర వెంకటరామన్ గారు 1930వ సంవత్సరంలో భౌతిక శాస్త్రంలో నోబెల్ ప్రైజ్ పొంది ఉన్నారు. వారికి ఆ నోబెల్ ప్రైజ్ ఎందుకు వచ్చింది అంటే 28 ఫిబ్రవరి 1928వ సంవత్సరంన వారు ప్రవేశపెట్టినటువంటి రామన్ ఎఫెక్ట్ అనేటువంటి దానిని పురస్కరించుకొని మరి వారికి నోబెల్ బహుమతిని 30లో ప్రదానం చేయడం జరిగింది. అట్టి భారత సంతతికి చెందినటువంటి ప్రముఖ సైంటిస్ట్ ఆవిర్భావింపజేసినటువంటి ఆ రామన్ ఎఫెక్ట్ను దృష్టిలో ఉంచుకొని మన నేషనల్ కౌన్సిల్ ఫర్ సైన్స్ టెక్నాలజీచే భారత ప్రభుత్వంకి ఒక రిప్రజెంటేషన్ ఇవ్వటం జరిగింది. అది 1986లో ఈ 28 ఫిబ్రవరిని ప్రతి సంవత్సరం జాతీయ సైన్స్ దినోత్సవంగా జరపాలి అని చెప్పేసి రిప్రజెంటేషన్ చేశారు. దానిని పురస్కరించుకొని 28 ఫిబ్రవరి 1987 నుండి మనము ఈ యొక్క జాతీయ సైన్స్ దినోత్సవాలని జరుపుకుంటూ ఉన్నాం. ఇప్పటి వరకు మనము 34 జాతీయ సైన్స్ దినోత్సవాలని జరుపుకున్నాం. మరి ఇది 2021వ సంవత్సరంలో జరుపుకునేటువంటి ఈ జాతీయ సైన్స్ దినోత్సవం అనేటువంటిది 35వ సైన్స్ దినోత్సవంగా మనం జరుపుకుంటున్నాం. ఈ నేషనల్ సైన్స్ డేని ఎందుకు జరపాలి అని అంటే, నేషనల్ సైన్స్ డే ఈజ్ బీయింగ్ సెలబ్రేటెడ్ ఎవ్రీ ఇయర్ టు వైడ్లీ స్ప్రెడ్ మెసేజ్ అబౌట్ ద సిగ్నిఫికెన్స్ ఆఫ్ సైంటిఫిక్ అప్లికేషన్స్ ఇన్ ద డైలీ లైఫ్ ఆఫ్ ద పీపుల్, to display all the activities, efforts and achievements in the field of science for human welfare. Moreover, to discuss all the issues and implement new technologies for the development of the science, to give an opportunity to the scientific minded citizens in the country, to encourage the people as well as popularize the science and technology. The objective is to make every citizen develop the attitude of questioning and reasoning. కాబట్టి ఈ అంశాలని దృష్టిలో పెట్టుకొని మనము ప్రతి సంవత్సరం కూడా నేషనల్ సైన్స్ డేని జరుపుకుంటూ ఉన్నాం. మరి 34 సంవత్సరాలుగా మనం ప్రతి సంవత్సరం ఒక్కొక్క థీమ్ని మరి అనుసరిస్తూ మరి యొక్క సైన్స్ డేని జరుపుకుంటాం. గత సంవత్సరం అంటే 34వ థీమ్ ఏంటిదనంటే 2020లో 34వ థీమ్గా ప్రవేశపెట్టిన థీమ్ ఏంటిదనంటే ఉమెన్ ఇన్ సైన్స్. ఈ సంవత్సరం 2021కి గాను 35వ థీమ్గా ఫ్యూచర్ ఆఫ్ ఎస్టీఐ అని చెప్పేసి నిర్ణయించడం జరిగింది. STI అంటే సైన్స్ టెక్నాలజీ అండ్ ఇన్నోవేషన్. సో భవిష్యత్తులో సైన్స్ టెక్నాలజీ అండ్ ఇన్నోవేషన్ అనేటువంటిది విస్తృతంగా వృద్ధి చెందాలి అని చెప్పేసి అనే ఉద్దేశంతో 2021కి ఫ్యూచర్ ఆఫ్ STI అనేటువంటి థీమ్ని మన భారతదేశం అనేటువంటి ఈ సైన్స్ దినోత్సవాన్ని పురస్కరించుకొని ప్రవేశపెట్టడం జరిగింది. సో కాబట్టి ఈ సైన్స్ దినోత్సవాన్ని ఉద్దేశించి మన కళాశాల ఇన్ఛార్జ్ ప్రిన్సిపల్ గారైనటువంటి శ్రీ టి జీవన్ కుమార్ గారిని మరి ప్రసంగించవలసిందిగా కోరుతున్నాను.
Thank you, sir. Thank you very much for this wonderful opportunity to discuss on the platform regarding the Science Day celebrations from the SR and Vijayanagar Government Degree College. And also respected convener Dr. V. Shantakumar sir and our beloved guest Dr. Reddy sir and the all participants and our beloved principal. Really, the prestigious Nobel Prize, it is a dream to every scientist in the career. Sir C.V. Raman, he has contributed many more to the Indian physics, not only Indian physics, to the world. Here, on that occasion, we are going to discuss our Lord guest about in strategic sector and career prospects for the science students is one of the fantastic topic, but also very useful to our students and participants regarding the construction of their own career in a science platform. So I hope participants get really the inspiring talk by our beloved guest, and I welcomes our guest and once again congratulating to all to participate in this. Thank you, sir. Thank you very much for this opportunity to me.
థ్యాంక్ యూ సార్, థ్యాంక్ యూ వెరీ మచ్. వాల్యుబుల్ ఇన్ఫర్మేషన్ని అందించారు. థ్యాంక్ యూ సార్. అలాగే ఈనాటి ఈ మన వెబినార్ కార్యక్రమానికి ముఖ్య స్పీకర్గా, కీనోట్ స్పీకర్గా ఇన్వైట్ చేయబడినటువంటి శ్రీ మల్లు వెంకటరెడ్డి గారి గురించి ఇంట్రడ్యూస్ చేయవలసిందిగా మన కళాశాలలో అసిస్టెంట్ ప్రొఫెసర్ ఆఫ్ ఫిజిక్స్గా పనిచేస్తున్నటువంటి శ్రీ రవీందర్ రెడ్డి గారిని, సైన్స్ అసోసియేషన్ మెంబర్ గారిని కోరుతున్నాను.
సార్,
వెల్కమ్ సార్.
ఐఎమ్ హ్యాపీ టు ఇన్వైట్ మై బ్రదర్ శ్రీ మల్లు వెంకట్ రెడ్డి as resource person in this international webinar on the occasion of National Science Day. We were roommates during our studies and shared everything since our childhood. He helped a lot, not only me, but also many friends. Sorry. Okay. Many friends to reach the highest position in their career ladder. Students could utilize his helping hand. He is very tactful and genius to tackle any situation in his profession as well as social life. So, from biodata for Mal Venkat Reddy, he did his BSc from SR&B GNR in the year 1995. He did his MSc from Osmania University, and he did MPhil from University of Hyderabad and MTech from IIT Delhi. He joined DRDO in the year 2003 as a scientist B. Currently, he is a scientist F and a head of NDE division in Defense Research and Development Laboratory. He supports more than 30 tactical and strategic missile projects and programs. He is certified as NDT level 3rd by American Society for NDT. He played instrumental role in establishing conventional and advanced missile inspection methods and technologies for system development and production. He is a known expert in inspection of a wide range of materials like metals, composites, ceramics, rubbers, propellants, powder metallurgy parts, etc. His areas of interest include advanced digital radiography, computed tomography, and infrared tomography. He works in collaboration with several DRDO sister labs, defense PSUs like BDL, Midani, etc., and corporate companies like Godrej, L&T, Tata, VEM, etc. For the last 10 years, he has been actively involved in training and certification of NDT personnel. He trained more than 600 professionals from ISRO, DAE, BEL, NPCIL, BDL, Midani, and from various private companies. He received several awards for his contribution. Some of those are National Technology Day Award for 2004, DRDO Agni Excellence Award 2010, Technology Day Orientation Award 2014, Innovation Idea Prize 2014, DRDO Special Award for Strategic Contribution 2014, Laboratory Technology Group Award 2015, IAS NT Best Chapter Award 2015, Laboratory Technology Group Award 16, ASNT Silver Medal 2018, and finally DRDO Performance Excellent Award in 2019. I hope you all enjoy the talk. Today's program on science and technology in Indian strategic sectors, career prospects for science students. Thank you all the participants who joined this program, and I invite Venkat Reddy to continue his talk.
Thank you very much. I hope I am audible. Am I audible to you?
Okay, it is audible.
Thank you. Am I visible also?
Visible, clearly visible.
Thank you. So, yeah. So, is it visible to you all?
Yes.
Okay. Thank you very much for your kind introduction. And good evening, all of you. This evening, I'm going to talk on science and technologies in strategic sectors, career prospects for science students. And as your faculty already discussed, As our faculty already discussed, this my talk is in relation with National Science Day celebrations, which is celebrated on 28th February every year to mark the discovery of Raman effect, and it started being celebrated in 1987. And as everybody of us know, and as everybody of us are proud, Sir C.V. Raman received his Nobel Prize in Physics in the year 1930. So National Science Day theme for 2021 is Future of Science, Technology and Innovation, Impact on Education, Skills and Work. So I think my today's presentation is very much apt for the occasion. And I would like to specially thank the chairman of this event, Sri K.S.S. Ratnaprasad, and today's in-charge principal, Dr. Jeevan Kumar, and the convener, Dr. V. Shanti Kumar of Chemistry, and members, Sri G. Surendra Reddy of Botany, Srimati P. Anuradha of Mathematics, Dr. Ravi Shankar of Zoology, and last but not the least, Sri Y. Ravindra Reddy. As he told, Ravinder was my roommate all throughout my life. And I'm extremely happy that he has introduced me this afternoon to all of you. And thank you very much for being there for me at every moment of my life. And to all the boys and girls online now, I was exactly like you all, pursued my BSc, MPc from SR and BGNR College in the year 1995. If I could become a scientist, I am sure many of you can reach much higher positions than me. I would like to discuss with you about the importance of sciences in our strategic sectors, discuss how sciences are being practiced today in the industry, and what you need to do to make science as your career. Okay. So I would like to introduce to you what is the strategic sector. The sectors, the sectors which are most critical for national security and are held under the control of federal government, that is central government. And why should they keep them under their control? Because of strategic reasons. If we import technologies, the countries which supply us, they'll have control on that. And also the countries who are supplying us, they will also supply to others. So that's why others also will come to know the technologies what we have. That's why it is always better to develop technologies within the country which are strategic in nature. The strategic sectors in India, especially today, are Department of Space, Department of Atomic Energy, Department of Defense, and along with these three strategic sectors, we have power, petroleum, coal and other minerals, transport, telecom, banking, insurance, etc. So all the other strategic sectors, starting from here to down, they are being allowed to invest, to be invested in by foreign and other institutional members, but especially in Department of Space, Atomic Energy and Defense, they are not being allowed. Why? Because they are really strategic sectors. So I just want to inform you about the strength of our strategic sectors. We have Department of Space having more than 17,000 employees and nearly 15,000 crores budget. And we have nuclear sector, which is biggest of all three, which has more than 50,000. Actually, 50,000 is a less in number, which is more than 50,000 employees and nearly 20,000 crores budget. And the Department of Defense, that is having over 30,000 employees and nearly 20,000 crores budget, where I am working in. So why it is important to discuss today? So all the three strategic sectors are going to see massive retirements between 2021 and 25, and they'll open a lot of avenues for boys and girls who are passing out during this time, and also who are continuing their education to masters and doctoral degrees and during this period, the 21 to 25. So there will be more and more job openings, and these job openings, because of current day situation, they demand advanced skill sets. So what are those advanced skill sets? I would like to introduce to you through my today's presentation. And when it comes to defense, the DRDO is divided into 7 technology clusters. The first is naval systems and materials, that deals with the navy, materials, shipping, and all those. Aeronautical systems, that is fighter jets and related items. Armament and combat engineering systems, that is battle tanks, armaments, and other related systems. We also deal with life sciences, where food and clothing for our services are produced, and electronics and communication systems. DRDO has a dedicated VSAT, and these electronics and communication system will deal with that. And microelectronics devices, computational and cyber systems to safeguard our properties and to safeguard the country from cyber attacks and everything. This wing will deal with that. And finally, the missiles and strategic system to safeguard our territories and country and strategic assets. And this is where I have been working for the last 18 years. So this DRDO establishments are distributed almost from Kashmir to Kanyakumari, evenly distributed at every place. And many labs are located in Delhi, Bangalore, and Hyderabad. Hyderabad is one of the biggest center where all the missiles and strategic systems labs are located. And out of these labs, in DRDL, Defense Research and Development Laboratory, which deals with the development of strategic and tactical missile programs. So in that I work. Okay. So when you take an example of a light combat aircraft, there are so many laboratories which are involved in the development of light combat aircraft. You can see here more than 150 laboratories, DRDO labs and private labs also involved in this. Now, what exactly these labs do? What exactly these labs do? They do science, engineering, and technology development. This is the most important aspect, and all the boys and girls who are online this evening, they have to notice this. So all these labs which are related to LCA program, a single program, almost more than 150 labs, and all across the country, they have been involved. So the importance of these programs, the science, engineering, and technology development which is happening across the country for a particular single program of LCA. And there are several tens, I think nearly 40 to 50 programs are going on under DRDO. And all these programs are being done in collaboration with public, private, and Government of India organizations. So here we'd like to discuss what is the difference between science, engineering, and technology. Science is establishing a fact which is already existing in nature by observation, analysis, organization, that is data sorting, and inferring out of it, and communicating and publishing the data. That is, for example, in simple layman word, discovery of usefulness of wood to take, that is what is science. And science gives us knowledge, and it is done by the scientists. So when it comes to engineering of new materials, new structures, and new mechanisms. Mechanisms means turning mechanism, folding mechanism, lifting mechanism. All those mechanisms are engineered by whatever the materials available, whatever the scientific innovations available. So that is done by engineers. For example, once the wood is known for its properties, and design of wooden frames is a engineering aspect. And when it comes to technology, a technologist who produces number of range of products from this engineering. So this, for example, when you take wood coming from science and a door frame coming from engineering, and the technologist would produce number of different types of doors which are useful for houses, temples, and infinite number of other applications. And when you go to a next example, if a scientist is observing some variation of capacitance by human touch in an electronic panel, and this design of panel with measurable capacitance is the engineer's job. And once this is established, and that will be used as touch screen for phones, tabs, car panels, AGs, etc. by technologists. So this is the way, hand in hand, they keep developing science followed by engineering and technology. And I would like to inform all the people who are online this evening, the maths is central and pivotal to all these innovations which are starting from science, engineering, and technology. So please believe that irrespective of our education, there is a scientist, an engineer, and a technologist in every one of us. Only thing is to focus and channelize our abilities to realize and understand it. Let's make a few examples. Let's take a few examples from strategic sectors to know how science is being used in. Okay. So, for example, if you take a missile as a case, and there are more than 1,000 parts in missile, and there are more than 30 different materials which involves chemistry, material science, and physics, like metals, composites, ceramics, rubbers, elastomers, propellants, and there are several other materials. There are so many variants in metals, like different alloys of aluminum, different alloys of steel, alloys of titanium, alloys of zirconium. All these are used as different materials for different purposes. And missile manufacturing, which involves computer science, material science, and mathematics, and missile aerodynamics, which involves physics and maths, and missile combustion, that involves physics, chemistry, and mathematics, and missile inspection also involves physics, mathematics, and chemistry. Missile performance testing, missile uses several other sensors and actuators like pressure, temperature, strain, proximity, position, push, pull, roll, pitch, yaw, etc., turn and eject. So many types of sensors and actuators are being used. And why I kept this missile inspection in red? Because I work in missile inspection. Because somebody who has to inspect a missile to its perfection should know all these aspects. Otherwise, he will not be able to inspect. And how the science of what we have learned in SR and Vijayanagara College during our graduation, how it is being useful, I would like to explain you, and I'd like to discuss with you this evening. Unfortunately, we are online. It would have been better if we would have been offline and I have been talking to you, but unfortunately it can't happen because of pandemic situation. But given an opportunity in the near future, I would like to come to our own college and meet you guys and talk to you, discuss with you, and invite you to join me in DRDL for a lab visit or so. So, what is the physics of missile inspection? If I want to discuss with you, the missile inspection uses basic principles of electricity, magnetism, light, and sound. It's very simple. What we have learned during our +2 and +3. When it comes to electricity, so electromagnetism, like X-rays, Coolidge tube, X-ray spectrum, electrons, protons, neutrons, eddy currents, photoelectric effect, Compton effect, pair production, and half wave rectifier, full wave rectifier, and so many other aspects of electricity are being used directly by us today. And when it comes to magnetism, we use magnetic lines of force, ferromagnetism, magnetization, induction, retentivity, saturation, coercive force, hysteresis loop, Curie point, Hall effect to measure the magnetization, magnetic induction levels. And we have been using all these words in day-to-day inspection activities which are happening in our place. And when it comes to light, photon, fluorescence, phosphorescence, infrared thermography, night vision, day vision of human eye, charge coupled devices, and everything we have been using for missile inspection. So when it comes to sound, we use ultrasound that is made by piezoelectricity, acoustic impedance, reflectance, transmittance, Snell's law, Young's modulus, Poisson ratio, and so many other elastic properties of materials being inspected, tested, and measured and given to various other programs. So besides this, we also use radioactivity, alpha, beta, gamma, alpha rays, beta rays, gamma rays, half-life of a radioactive substance, and also thermoluminescence, Geiger-Müller counter, ionization chamber, like other aspects like diffusion, surface tension, viscosity, capillary action, oxidation, passivation, galvanization, and physisorption and chemisorption. And we also very frequently use and measure crystal structure, grain boundaries, dislocations, defects, X-ray diffraction, Bragg's law, etc. The entire syllabus of BSc Physics we use in missile inspection. So there is nothing new. But what is happening in the industry? I would like to take a few examples and explain you how what we have learned in SR and BGNR and what you have been learning today will be useful for missile inspection applications. And not only missile inspection applications, missile design, missile production, missile testing, as well as missile inspection. So all these aspects, so the entire missile development life cycle, testing life cycle, deployment at different places where the temperatures are minus 40 degrees to plus 50 degrees, almost 90-degree variation across the country. And also when the missile goes up, it will see almost minus 40 degrees within a few seconds from when it is launched. So from plus 35 to minus 40 degrees within few seconds, what kind of materials are required for that? So all those aspects are basically, they'll come from basic chemistry and basic physics and basic mathematics. Without mathematics, there is no physics and there is no chemistry. There is no biology even. So when it comes to missile inspection, exactly similar to the human being inspection, we also do X-ray inspection of missile system, and how it is different and what we have been doing all these years and how it is critical for the success of missile programs. I would like to explain you and seek your attention. And please bear with me. I'll keep going a little rapidly here. The human being, there are so many, from head to toe, there are so many different types of X-ray radiographs for different purposes and different evaluation. They do it. And similarly for missile also, we do that. So like this, there is an X-ray source here. And when the X-ray source is a simple Coolidge type of X-ray tube, and when you use acceleration potential and the electrons are being accelerated and made to fall on a target of this X-ray tube, and the tungsten target which seeks these electrons, and there are some excitations and de-excitations happen in electron energy levels. And because of excitation and de-excitation, there will be emittance of X-rays from the target. So there will be a window from which these X-rays will come out, and these X-rays are used for inspection of missiles. For example, here keeping a film, the film itself is a huge chemistry and huge physics, and there is plenty of mathematics involved in that. Now, I'd like to inform all the boys and girls online, we are using day to day, hour by hour, all the aspects of physics, all the aspects of chemistry, and all the aspects of mathematics, what we learned during our graduation in SR and PG degree college. Come on. So, where is science here? The science here is simple Coolidge tube, which was used by Roentgen for production of ionizing radiation, which is named as X-ray beam. That X-ray beam has a spectrum. Spectrum means the intensity distribution at different energy levels, that is different wavelengths. And this spectrum, when it is piercing an object, because of object's composition, because of object's thickness variation. So when these photons are falling on this object, they will get absorbed due to photoelectric effect, Compton effect, pair production. Yeah, we keep measuring all this photoelectricity, Compton effect and pair production, followed by electron-positron recombination. Okay, so the photons reached the film, form the meaningful image. That image will show us the density distribution of the object. For example, here you can see a crack kind of discontinuity within this missile. So X-ray film development itself is a huge chemistry department, which our people and scientists will keep doing here. And if you see, and there is a missile here, it's radiograph, and there is a missile part which is imported and also developed, mimicked, and that also a part here. And here you can see there is not much clarity. Clarity means we will not be able to interpret what exactly is that. And what we have done with the help of all engineers and technologists in our place to improve this image, that I'm going to explain to you in the coming slides. So there is a crack here. We are seeing a crack image, and there is an impeller of a pump. This is a fuel pump impeller which is used in missile engines, which are liquid propulsion engines. And this fuel pump, we want to measure the exact output of this fuel pump. For that, we want to radiograph and measure this cavities. Okay, so that is not possible simply by radiograph. And you take missile tip. So normally a strategic missile of the range of 2000 kilometers or more, they use re-entry vehicle structures which are carbon materials. So those re-entry vehicle structures are made up of composites. They have to go out of atmosphere, and while re-entry, because of kinetic heating of air, they see a lot of heat, and they have to safeguard all the electronics on board. For that, they have to be very much thermal insulative properties and also structural stability at high temperatures. Those kind of properties are required. So for that, we use plenty of composites which are developed in-house in DRDL and sister laboratories of DRDO. And there is another carbon silicon carbide material and being radiographed here, and which shows some kind of darkness here. So what is that darkness? So the images what you have seen, they have details, but we need a lot of expertise to interpret them. How engineering made this interpretation easy and how this is solved is by cross-sectional imaging, that is called CT scanning. Okay, so because the engineering materials are very thick and very high dense, whatever the human CT scans which are available in hospitals, we can't use them. And also the foreign countries where the technology available, they will not supply us because of strategic reasons. So that's why we started developing.
PowerPoint presentation not appearing.
Oh, is it?
PowerPoint presentation.
No, sir, it's visible, sir. Your presentation is visible.
Is that okay?
Yes, sir, your presentation is visible.
Okay, thank you. Yeah, so it is similar to the human brain scan, for example. If you are taking a side scan image, and we see only this complex structure of human being, where if we are able to take a cross-sectional scan of like this, as if you are cutting across the screen, we'll see the top view where the structures are very, very nicely seen. And interpretation for the operator, for the technician, for the technocrat and scientist, it will be very easy. And how we have developed that. For example, if this is the object, and that object is simple radiograph, which is taken normally when my leg was broken, I have gone to hospital and they have taken a radiograph, and doctor said, okay, you have a crack here. I didn't see that crack in that radiograph, but he knows it. And if I have taken a CT scan of that, it would have been very, very easy to interpret that. Similarly, we have used a CT scan of this, taking a cross section here, which shows all the details, taking another cross section here, which shows plenty of details here. Okay. So this is the algorithm. If this is the object and there is an X-ray source, there is a collimator. The collimator will give, and there is a digital detector, X-ray digital detector, and there is a CNC, computer numerical control manipulator, which is computer control, and computer will control the source, control the manipulator to turn the table, and also computer will seek the data from the detector. And this is called 2D computer tomography. It gives the cross-sectional image. So what is its beauty is, its cross-sectional image will give us, will remove the interference between features across the thickness. So all the interference features, what we are seeing here, which are due to radiograph, are removed in the cross-sectional images that we have developed in-house because of the demand. So we started in the year 2001 like this, and we improved by 2002 to make, actually this in fact was a workshop waste, and we used in some rocks. Are you seeing some rocks here? So those rocks we have used for supporting the objects to prove the system in the initial stages. And Dr. Vijay Sundaram, I would like to credit this development to Lieutenant General Dr. Vijay Sundaram, who was Director DRDL at that time, and he was the man behind this program. And we started developing inch by inch by putting an X-ray source here, and an object manipulator here, and an object on this, and a detector on the top of a workshop waste. Okay, so this was a system envisaged in the year 2002, followed by a second system which is stabilized, and we developed in the year 2003, and we have gone for a bigger CT system development, which is in-house in the DRDL. The system, the manipulator was developed by Hindustan Machine Tools, HMT, Hyderabad, and all other systems are integrated by us. Software program was done by us, and we have proven this system. That system was fantastic, and it started giving all the results. So we have done system calibration. Is there any trouble seeing my presentation? Is that okay? Can anybody speak out?
Yes, sir, it's okay.
Okay, sir. Okay.
Fine. Thank
okay,
you.
sir.
Thank you. So
Welcome.
this is what is the 3D CT system which I've been using all these years, and this has given incredible data. So we have designed various material phantoms for system calibration, for density differentiation and defect analysis, and all those things. We have designed several phantoms. Phantoms means the artificial objects with defects in them. And we have used a lot of mathematics, like mathematical projection acquisition, and followed by various offset correction, gain correction, sinogram generation, and also calculating various software filters and application of a Fourier transform on this and Fourier series calculations. That means time to frequency domain calculations. All those things we have used, and plenty of mathematics. Actually, I cannot explain because it takes a lot of time to explain mathematics behind all this. But if this is the object and we start collecting the data, passing the beam through that at different directions and do all these operations, and at the end we'll end up with a cross-sectional image which is beautiful, and there is no interference between different features of this image. So this gives the strength to the operator or the interpreter who has been seeing the data. So I'll show you, for example, you have seen that missile radiograph, and if I take cross sections here, and there is a small defect which is seen here, normally this defect, okay, we'll just leave it. But otherwise, if you take cross-sectional images, we have problem here, and the problem continues at different sections. And if you go down a little and there is a problem here, there is a void kind of thing, and there are so many debonds between different layers. So this is the beauty of this technique, which is the marvel of engineering. Actually, the basic science is this image and the engineering is this image, and using this engineered technique for several of DRDO applications is the technology. So the science, engineering, and technology, hand in hand, they are being used by us every day, day to day. So you see here a nozzle. This is actually a reconstructed image, a 3D reconstructed image. This is not a solid model, which normally a mechanical engineer would generate on his desktop. So the real object have been scanned by us on this system, and finally different defects, cracks, and their locations in different planes. The one cut this, another cut this, another cut in this, all XYZ planes, XY, YZ, and ZX planes. All these planar cuts we can give, and it gives us a virtual walkthrough, and that information can be fed to further algorithms to automatic defect recognition. And you know, this makes the operators and interpreters and scientists' life very easy by automatically detecting number of discontinuities which are there in the rocket motor or missile parts. So the beauty of this system is the improvisation, the quantification of data. Qualitatively we are seeing, but we don't know where is the location of the defect in the geometry. So to know the defect location, to know the orientation, to know its size, shape, and all those things, we need quantitative tool, which is similar to cross-sectional imaging by computed tomography, and also ADR softwares, what we have developed in-house. Okay, I would like to show you a small clip here. I think it will play. Yeah, is it playing, sir?
Yes, sir, it is playing.
Yeah, okay.
Yes,
Yeah,
sir.
yeah, please concentrate. Various sections of a hardware. So we take a real hardware of this, for example, a cast aluminum, that will be loaded into this CT scan system, and in real time, while rotating and passing the X-rays through that, and we'll collect the data. So once we collect this data, the data file will be uploaded to a computer algorithm. That computer algorithm will calculate all the essential parameters, including its size. And you can see here, virtually, we have reconstructed the entire 3D of the object. For example, you are designing an object and making some drawings. That is the concept. So once the output of manufacturing process comes, we can compare the actual design and the output, and we can differentiate between what is the tolerance, whether it is really that close to the design or not, we'll be able to check it. And also we can go through each and every dimension of it and try to know what is the deviation the component has got. So once that is known, we can also know what is the internal defects. For example, if we are going to drill another hole here, whether the defect really goes in that hole, whether it can be acceptable or not, we'll be able to tell. For example, you take this as a cross section and try to know where is the location of a defect. For example, if this is acceptable, so if any unacceptable defect which is falling in a hole which is done in the subsequent operation, if that is inside or outside, we'll be able to know. If it is inside, that defect will be removed in the subsequent operation and this item can be acceptable. And there were so many instances we avoided rejection of items with this technique. So some good items which are manufactured, which are good and which are useful, and rejection of that can be avoided using this technology. And so that's what about the CT technology, what we have been practicing. I'll take another example. This is what we have discussed so far is electromagnetic spectrum, that is X-ray spectrum, gamma ray spectrum, and all those spectrum. And now let us try to discuss about the ultrasound, for example, which is elastic wave in materials. So the sound is a vibration that propagates as a mechanical wave of pressure and displacement through the medium. So matter should be present for the sound, unlike electromagnetic radiation which travels through the vacuum. Sound cannot travel, sound needs medium. Okay. So sound propagation is transfer of energy but not the transfer of matter. So if you see the wave and take the oscillation, this oscillation, so oscillation in time can be represented as a sine wave or a cosine wave. Okay. So the beauty of understanding of ultrasound is in understanding of an oscillation, okay, and its properties. So the sound has different bands like infrasound, infrasonic, audible, and ultrasonic. So anything more than 20 kilohertz is called ultrasonic. These ultrasonics has every property as a normal audible wave, like wavelength, frequency, velocity, etc., amplitude, for example, pitch, and all those things they have. And all these properties also being measured. And why do we use ultrasound for inspection? Actually, when we go to an diagnostic lab of a medical hospital, there also the abdomen scan, pelvis scan, ladies, what is that called, when they are pregnant, that baby scan, and all those scans they keep doing. So why do we do that? Why do we use ultrasound? So ultrasound has directional properties, and it is shorter wavelengths, and the wavelength is near to the defects anticipated in that materials. Material may be a human body or a missile body, and it is silent. It is not louder at all. So because if it is silent, it will be very useful. And it is non-ionizing radiation. It will not penetrate and change the human cell structure. Okay. So it has also the velocity depends on the medium of travel. It doesn't depend on frequency. Okay. The velocity depends only on medium of travel. Here is the elastic modulus and density. Okay. So we have 4 modes of ultrasound, like longitudinal waves, transverse waves, surface waves, plate waves, etc. So all these modes we are using in missile inspection. So why we talk about all this mathematics, physics, and also at a later part we'll know the chemistry of ultrasound. Okay, various variation of chemistry in materials, how it affects ultrasound propagation. That also we have been studying for different materials like composites, ceramics, metals, different alloys, and different surface roughnesses, passivation, different heat treatment in annealing conditions. So all these things, they will affect the propagation of ultrasound wave. So these are the waves like a longitudinal wave and this wave, and these all equations, and you can mug up through internet. And this presentation I am going to share you. This presentation belong to the viewers, boys and girls who are online this evening. I'll give you this presentation. You can have this presentation leisurely. You can read. Okay. So ultrasound is generated using materials like quartz crystal, lead zirconium titanate, and barium titanate, etc. Okay, so there is ultrasound. The principle of ultrasound depends on piezoelectricity. Okay, piezo to electricity, electricity to piezo. That means pressure to electricity, electricity to pressure. So pressure to electricity will give us detection. Electricity to pressure will give us source. So that way the ultrasound is generated and it is pumped into materials. And once the different defects or different anomalies which are there in materials, if that reflects the ultrasound in different directions, that reflected ultrasound we will capture, and we will try to understand how the material is, what is the health of that material. Similar to what we see our kidneys, gallbladder, and all those scans, what they do in the hospitals. Okay, so depending on the size of defect in a material, this yellow is the material and different size defects, and that will reflect the ultrasound, incoming ultrasound. This is an ultrasound probe, and that reflect like this. So why it reflects like this is due to the spherical nature of the ultrasonic wave. And like this, for example, the instrument of ultrasonic testing looks like this, and there is a probe. So when the probe is kept here, and we'll get a signal. So that signal will tell us what kind of health the system has. If there is no defect, we'll get a signal. If there is a defect, we'll get a different signal. So it is the expertise of the operator, depending on whom this ultrasound will run. So here also I would like to show you what kind of engineering, and the basic ultrasound, piezoelectricity, and all these things is basic physics. And the generation of ultrasound using lead zirconium titanate, quartz crystal, barium titanate, and other ceramic crystals is again physics and mathematics. So how it is improved using engineering and technology, that I am going to show you. So there is a pulse which will reflect, and if there is no defect, it reflects from the back wall, and you will get one signal. If at all there is a defect, you will get a signal in between. From this, we will come to know what kind of defect it is, the shape of this pulse, the size of this pulse, the height of this pulse, and also the signal dynamics. It is called ecodynamics. Ecodynamics, because everybody might have seen, and definitely ladies and 40 plus guys, we might go to hospital for our abdomen scan, this scan, that kidney stone scan, gallbladder scan, or whatever the scans. So in that, the operator or a doctor or a radiologist keeps modulating or undulating or moving like this on our belly, up and down, left and right, top and bottom. He keeps moving it. Okay, by that movement, he's trying to capture the required information by the ecodynamics. So how the echo is varying, and what is the size, shape, location, and measurement, those all things will be informed, and it is inferred. Okay, so there is a lot of mathematics again to find out different sizes. There is a weldment in material, so we can do a lot of studies, and by different inspection coverages, by angle beam of ultrasound, and then like this, for example. So he will move like this, and he may move left and right. He may wiggle this, like turning this, and he may angulate, and he may get scan normally. So this is what is engineer or a technician or a technologist or a technocrat keeps doing in his lab, similar to what our doctors, radiologists, they do in their diagnostic center. So from the data, we'll be able to use all the mathematics, all the trigonometric equations, the geometric equations will be used, and we'll try to interpret where is the location of discontinuity. And we need a lot of expertise in interpretation of this data. So how engineering can enhance the interpretation? That's what I would like to show. There are so many transducers, so many blocks for usage, for finding the different applications. And again, it's difficult to interpret ultrasound signals. Let us see how engineering made it easy. So instead of one crystal, if you take multiple crystals, like 8 crystals, 32 crystals, 16 crystals, 128 crystals, so on. And each and every individual crystals will generate ultrasound. If that generation of ultrasound is modulated, if the generation of ultrasound is phased, or the firing of this elements, if it is sequenced in such a manner, you can do some kind of beam steering, because it's a spherical wavefront. That wavefront, you can turn it from this direction to this direction by timing of firing of these elements, individual elements. So the signal interference itself can be used for beam steering. This is the engineering marvel. Okay, so like that we can use fixed angle scan. So keeping the probe here, you can change the angle, you can change straight, same straight probe can be used as a refracted compression and refracted shear wave and multiple depth scans. All these scans are possible. What they do in medical scanning, similar to what they do in medical scanning, same probe can be used in different applications. Whereas here this is fixed, and in case of this we can get full, or we can use a small number of crystals to generate a required beam, and we can turn this, we can steer this, we can focus this, we can do plenty of operations. For example, this is what normally normal development in ultrasound. We have to see the signal, and many defects may give similar signal, and it is very difficult to interpret. Whereas if we can image, if we can use these signals and form an image, and it will be very easy, because no two defects will give the same image. Okay, many number of signals can give same type of defect. Okay, many defects can show similar signal, but many images will not be shown from different defects will not show the same image. Okay, so from this methodology, we will be able to use imaging as some kind of mathematics, physics, and also engineering are used to make this sectorial scan actually. Okay, this is say straight scan, and this is angle scan, where you are seeing number of defects. Not only this, here there is some kind of defect size variation here. So whereas, this is another scan like this, and we'll see the defects which are there like this. And if you can see, there is something called full matrix capture and TFM technique that refines the image to give the best image. Here you can see all this, like that, and curvature. All this data can be plotted here. So this is a technique which is developed by engineers and technologists based on ultrasound. The basic ultrasound principles, they don't change. The science behind ultrasound will not change, but the refinement by engineering and technology, that will change. So how the signal, here the signal is like this, and how the signals from different probes can be taken and formed an image, so that the operator or interpreter's life will be very easy, because the interpretation will be very easy. And the technology can be used interchangeably between different areas like medical diagnostics, then wood. For example, if you see concrete bridges, The bridges which are there, metro pillars in Hyderabad, are so many bridges in Khammam. They are coming up recently. Those bridges can be inspected using this. So its range of inspection goes from human beings to the concrete inspection and even missile inspection today. We have been doing this. Okay. So not only that, we want to do some kind of automatic inspection. See the beauty of this. So the some labs in collaboration with the DRDL, they have developed some techniques where you can move something like this and it will show defects automatically. So the location, the orientation, the scanning geometry, everything will be loaded, and the presence of defects at different 3D geometry at different locations will be mapped. And using automatic defect recognition programs, so this manual intervention also can be avoided. So the computer with artificial intelligence, today in the years to come, we have been talking for the last 4 or 5 years, usage of artificial intelligence in every area of science and technology. So that artificial intelligence can be used here in combination with the automatic defect recognition software to infer the data, to analyze the data and act and pass the judgment saying whether it is acceptable or not. We can do that. For example, this is an independent, almost standalone robot. You can see how a robot with a phased array, which will scan and find out a defect. Are you seeing a defect here? Yeah, this defect. So this is the beauty of engineering and technology, which enhance people's lives through various advancements. So it will be very easy for the operator to interpret this data and to accept or reject the items. Why? Because in the years to come, as the day is going on, so many advances in materials, so many advances in systems, so many advances in the strategic sectors like the nuclear industry, for example. And we even developed some technologies which are inbuilt. For example, there is a cross-country pipeline and there is a workshop where you can embed your sensors. So automatically when you switch on, they will take data and they will pass on those data to the remote computer. And recently we have developed 2 technologies. I forgot to mention in these slides. The 2 technologies are, one is drone-based technology. For example, high-raised structures where there is unacceptable radiation, where human beings are not allowed, and very high-rise structures where it is dangerous to reach, and some confined areas where dark areas or human beings cannot go. The micro drones can go with sensors, with Wi-Fi or with the cellular connectivity. They can go and they can collect the data and send to us, and also we can take the drone out. That is one technique. Another technique is IP-based technique. The sensors and actuators, for example, if you take a aircraft, the wing, the fuselage, the structures, the fighter jet, for example, light combat aircraft, which is developed by DRDO. And we have so many sensors already embedded during manufacture. Those sensors, simply by mobile phone, you will be able to activate them and collect the data frequently. So every week or every month, every fortnight, you will be able to capture the data and study the health of the aircraft. So that is being done. So robotics, artificial intelligence, drones, and remote inspection, IP-based inspection, internet-based technologies, all these things are left and right being used in the industry. So now we have seen electromagnetic spectrum in action. We have seen acoustic spectrum like ultrasound in action. Now let us try to know a little bit about magnetism and other things. And I hope I have time, isn't it, sir? Can somebody confirm?
Yes, sir.
Yeah. Okay. Thank you. So this magnetism, how we can use magnetism. So we know magnetic materials are categorized into diamagnets, paramagnets, and ferromagnets. And we all know that ferromagnets will have magnetic domains, which are localized magnetizations, and these localized magnetizations are arranged in different orientations when there is no field applied, so that the resultant field will be zero. Okay, so once we started applying the external field, so and after application of first external field and remove that field, then during the application of field, the local this domain magnetizations, they are aligned in one direction, the field direction, and the resultant magnetization, induced magnetization, will be there here. And once you make this applied external magnetic field zero, even after that, because of presence of these magnetic domains, that is called magnetic domain wall pinning. So due to that effect, they will not go back to the original virgin state. So they will retain some magnetism, that is called retentive magnetism or remanent magnetization. Okay, so that remanent magnetization can be used for studying materials. How we'll know. So we know magnetic permeability, again, that is in induced magnetization by applied magnetization. Magnetic field strength, actually induced strength by applied strength, will give us this permeability. So the diamagnetic is 0, paramagnetic nearly 1, and for ferromagnetics it is very high. So in case of ferromagnets, what happens when a magnetic material which is magnetized into some level and it has a crack or a break? So this is a break here and there is a crack here. So once it is broken, the new magnetic poles, north pole and south pole, which are opposite to the existing poles, will occur. So there is a north here and a south will come here, and there is a south here and north will appear here. So when there is a break, but often what we see in engineering materials and missile materials, especially nuclear materials, aerospace materials, aeronautical materials, and space materials, we don't see a break, but we see a small crack. So what will happen when there is a small crack? So because this cracked discontinuity, which is filled by air or oil or other materials which are non-magnetic in nature, so in non-magnetic places, so this is the magnetic flux density. So in ferromagnetic places, this is the flux density. So it will get rarefied here, not densified. Densified in ferro and non-ferromagnetic materials. So the lines of force will be sparse and your resultant magnetization here, magnetic induction, will be less. So exactly here also the same thing happens. So the inside this material, magnetic lines of force will be very dense, and here they'll get rarefied. So in the process, they'll come out because of this rarefication. So this is a non-magnetic material embedded here. So because this is non-magnetic, it will expel the magnetic lines of force. So once the magnetic lines of force are expelled, there is something called leakage flux at this location. So underneath there is a defect and there is a leakage flux. So wherever there is a flux leakage happens through the surface, and this surface will attract magnetic particles like iron chips, iron powder, what we use for demonstration of magnetism in our physics lab in early, maybe in our 9th class. We have seen magnetic powder and bar magnet. And we used to put the bar magnet outside in the sand so that we collect a lot of iron filings, iron powder, which is there already in the earth crust. So those particles will be attracted here. So by magnetizing this item and sprinkling some magnetic powders on the surface, so wherever it attracts magnetic powder, there is a defect. So there is a flux leakage, there is a defect. So if a circular object which is disc shaped, not disc shaped, this is a ring shaped object, which is circularly magnetized, and there is no magnetic pole which is coming out. Whenever there is a break, then flux leakage will happen and it will show pole formation, and the pole formation will attract magnetic sprinklings, powder, small powders, and it will show the distance. What is the beauty of it? And there are so many inferences about orientation and near to surface, far from surface. And, so the orientation which is perpendicular to the lines of force, which is parallel to the lines of force. So it is evident from here that the defect which is perpendicular to the lines of force will be shown very evidently, which is parallel to the lines of force will not be shown that evidently. Okay, so that now next time we'll be able to magnetize this item with this field, the field which has direction perpendicular to this, so that this will be shown and this will not be shown. Okay, so it uses Ampere's right hand law again. So it comes to electromagnetism. Okay, so what I mean to show here during this my presentation is what we have been learning from our intermediate days, from our BSc days, from our MSc days, entire spectrum of aspects of physics, chemistry, and mathematics will be useful in technical jobs like DRDO jobs, ISRO jobs, and Department of Atomic Energy jobs. And so many other companies who are ancillaries, who are developing various products to these organizations, they also use same technology. So at the end, I would like to discuss what we need to get into those jobs. Okay, so we can magnetize in different orientations, like this is longitudinal magnetization and this is circular magnetization in two different orientation. Okay, for this defects, we have to use this kind of magnetization. For this defect, we have to use this kind of magnetization, so that if we use two perpendicular magnetizations, circular and longitudinal, okay, we'll be able to cover entire gamut of defects. So it's very easy, but at the same time, we have to develop various techniques, mechanisms, and various devices. For example, how do you induce magnetization or magnetic field? So that can be done by a permanent magnet. Put two permanent magnets and sprinkle powder here, because we know how lines of force will go. Or you take a coil, encircle the object and give electric current, and use the right hand thumb rule. Okay, if this is current, this will be your magnetic field, and if this circular is the current, and longitudinal will be the magnetic field. So exactly same principles of physics, basic principles of physics will be used, and that will be informed to this technician, so that he will use the same basic principles for defect detection in various materials. Not only defect detection, we are characterizing the materials. We are characterizing the magnetic particles, magnetic properties. For example, how do we measure magnetic field strength? And another important thing, okay, we have magnetized this and found out there is no defect, and we have to demagnetize this. How do we demagnetize? We have to use a demagnetizer. What is a demagnetizer? A demagnetizer uses hysteresis loop of this, and we have to measure the hysteresis loop, that is induced magnetism with respect to the applied magnetism. Applied magnetic field will be on x-axis, and your induced magnetic field on the y-axis, and your S-shaped curve, 2S curve, will give you the energy which is stored. Actually, the area under the curve is energy which is stored as a magnetic energy. So with that, the properties of that curve, we will be able to know by what is required for removal of the field. So the coercive field, which is negative, where the applied magnetic field will be zero. Sorry, applied magnetic will be negative, so that the induced field will be zero. So that field we have to use so that whatever the magnetization which is induced due to this inspection, that will be removed. Why we have to remove the magnetization of the after the testing? Because once the item is inspected, if it is going for subsequent operation, or if it is a bearing, or if it is used in some moving part, so it will attract all the iron filings and it will keep rubbing. So to avoid that, so another important thing is, if you are going for welding, so welding uses electrons, electric current. So we all know that the electric currents means electrons, because they are charged particles, they will be deflected by magnetic field or electric field. So in this case, it is a resultant magnetic field which will defect electrons, which will defect the electron flow. The arc of that welding gun will be deflected. That is called arc blow. The minute you keep the torch for welding, it will immediately blow off. So for that reason, for performance of the item, we need to know the physics. For demagnetization of the item, we need to know the physics. For magnetization of the item, we need to know the physics. For welding of the item, we need to know the physics. Not only physics, you need to know the mathematics, you need to know the chemistry of all these materials, mechanisms, and various other aspects which are involved in that. So here, anyway, okay. So again, engineering adds value to inspection. So better detectability by adding high eye sensitivity. For example, red in this case, I have enhanced this image. That's why we are able to see this. So normally, human eye is sensitive to red, because of its higher wavelength, it propagates longer distances. That's why it is used in signals. But to increase or improve the sensitivity of a human eye for defect detectability, we can use fluorescence. So if you can coat the magnetic particles, the slurry of magnetic particles with fluorescent material, which will give yellowish green light, or what is this yellowish green light, to which human eye is highest sensitive. So that yellowish green light is an addition by engineering, is an addition by technology to the basic physics of inspection. So the basic physics of inspection is magnetization, magnetic materials, domains, coercivity, applied field, induced field, hysteresis loop, and saturation magnetization, and all those things. But whereas the addition to means additional sensitivity the human eye can inspect we can get that by adding fluorescence to this. We know fluorescence, again, it's a chemical and physical property. So that can be used for enhancement of results, improving the results. See the beauty of science, engineering, and technology. So for example, here there is a weld repair. You see here this is a welding of two materials, the one material and another material, there is a welding, and there is some kind of mess up here, repair. So the magnetic lines which are formed due to repair, and magnetic lines which are indications which are formed due to cracks and defects present here. There is a crack here. So this adds to our confidence. This will give a lot of confidence to us to inspect these materials. And not only manufacturing, inspection, and the inspector should know what a manufacturer can go wrong, where the manufacturer can go wrong. For example, in this case, he has used wrong repair parameters. and immediately using magnetic particle inspection, the magnetic lines of force and expelment of magnetizations, which will show up in fluorescent magnetic particle inspection. So this shows the wrong usage of welding parameters. So somebody who is manufacturing, the fault of him, we can inspect and show that, boss, you are at mistake, you have used wrong parameters and you got some results which are unreliable, and which leads to cracking and defected item. So all these things we can do by what? By basic science followed by engineering and technology. So this is the way in which the R&D activities keep going in strategic sectors like DRDO, Department of Atomic Energy, Department of Space, and so many other strategic sectors. So what are the areas of interest here? Design. Design is not of engineers. A scientist can design. You and me can design. Everybody of us is a designer. Are we not doing day-to-day designs at our home? If something is not, if something is straight and it's not holding, then we'll make it bend and we'll hold it. Is it not a design? Everything what we do in real life is a design. Everything which gives additional feasibility, additional comfort, additional use of that material or a structure will be a design. At the end of the day, whether it is a good design or a bad design, we have to decide based on its utility and all those things. But every scientist, everyone who has studied science is a designer. It's not that engineers of a mechanical engineer or aeronautical engineer. Now, if I would have become a mechanical engineer, if I would have become an aeronautical engineer, I'll become a great designer. No. And you know, we have a principal designer of DRDL. Who doesn't know all this CAD, CAM, all these softwares? CATIA, ProE, ANSYS, this AutoCAD, then SolidWorks, so many softwares are there. He doesn't know, he knows none of them. How he has become a great designer? He knows the sense of geometry. He knows the sizes. He knows the criticality. He knows the job. He understands the basic physics, basic chemistry, basic metallurgy of the item, and basic utility of this item in an application, where different kinds of loads will come, where temperature will come, where chemical, the roughness, means what is that, chemical attack may come. So all those things needed for a designer to decide what kind of design he has to make. Not AutoCAD, not the tools. Tools are just aiding. Okay, you go and sit in AutoCAD boy and he'll make whatever you want. So here you are the designer, not the AutoCAD boy. Okay. So then let us, these are a few of the examples what I'd like to share you where in strategic sectors we have been using our physics, our chemistry, and our mathematics, what we learned in SR and BG in our college for 3 years. We have been using them day to day, every day almost. So what are the career options for sciences? So here, before career options, we'd like to know what are the requirements of current or today's industry. The today's industry wants ready to use, ready to deploy manpower, skilled manpower. What is skill? It's a personality attribute. Even though you are training for years, somebody will not get skills. Without any training, somebody will be highly skillful in the first attempt itself. Okay. Skill is the zeal of a person, the acquisition of knowledge, the orientation of a person towards the job. That gives you skill. Skill is a natural talent. Okay. Training to do the job. So for example, everybody of us, we started using our smartphones. Who has trained you? Nobody has trained you. You got a zeal, you would like to understand, you would like to share photos, this, that, and all those things. You want to do banking operations, you want to make so many types of videos these days. So many YouTube videos people are making. Okay, so all those videos you are making, how? Because of your zeal, you have acquired the skill. Nobody has trained you. So ready to deploy manpower. So if you are unable to be deployed, you need training. Where do you get training? There are so many institutions across the country, across all the states, where training organizations are there. People see there are only software training which happens in Amirpet. No, not only software training. There are so many organizations which will give hardware training. People undermine that. So many people are acquiring it. And spontaneity. Spontaneity means you are having knowledge in physics. You are having knowledge in mathematics. You are also having knowledge in chemistry and metallurgy and all those. All those. But how instantaneously you can use that knowledge for a particular application? For example, you are given a task of inspection. You are given a task of design. You are given a task of manufacturing. You are given a task of making something. So immediately you will think, okay, this is the way. If it is made, then this will give good result. How do you do that? Because you know it and you will be able to envisage and visualize it. So that is called spontaneity. Spontaneity will give you a lot of instantaneous result, instantaneous application of the background subjects what you have learned over the years of your education. Okay, so and one should be independent and self-motivated. Okay, independent. You should be able to do the task as a team member or as independent as possible, and he should be motivated to the task. And you know, because of archaic education systems, what we have been following for several years, this kind of self-motivation and being independent, that kind of culture is being lost. Okay, and thank God we all have been, myself and Ravinder Reddy, we used to be in one room for many years. And you know, in the morning, when you get up at 5 o'clock, when you get up at 5 o'clock, your books automatically fall on you and the lights will be on automatically, because that alarm with key. So that key alarm, there is a thread. So once 5 o'clock that alarm rings, then it will pull that thread, and so many bowls, utensils and all those things will fall, so that there will be a big bang of sound, and all the books which are kept on a strip of wood, that strip will be tilted using that alarm pull, and all the books will fall on us, and there will be big bang sound, and the same big bang sound will switch on the toggle switch light. That's all. Take the book, then uncover yourself, take the books and start reading. See the engineering. Where is science in that? There is no science. Engineering, it is engineering. So that's why I want to inform you, everybody of us has an engineer in us, has a scientist in us. We have to open our eyes, and we should be independent, self-motivated, and we should be able to communicate. Okay, and an independent and self-motivated person can go to leadership. You know, there are so many in the industry. If you take Tata, okay, leaders are nurtured. In Tata, like Indian administrative system, there is a Tata administrative system. There, very young people who are having independence and motivation, they will be nurtured separately so that they'll go to top management. It's happening. Nobody knows in the country about that. Very few. We are also informed by Tata people. And very young guys will be leading the teams. How do they do? Because they have a zeal of learning. They are highly skilled. They are well versed in subjects. They are independent and motivated. And they are highly dedicated. In addition to that, they have ability to communicate. And you know, a singer like Goreti Venkana, okay, Galli Sinnadi, like that songs he sings. Okay, and every song, every word he uses is highly beautiful and it pierces to the heart. Why? Because he know how to use those words in combination, how to make sentences using the words. So that's called skill, talent. Okay, and he knows how to communicate, the ability to communicate. He has the ability to communicate. That's why he's been rewarded as a great singer. Okay, and also the competitive spirit. So competitive spirit, you are not supposed to be afraid of anything. And my hobby at my early days of education is to get up early in the morning. And Ravindra Reddy's hobby is to stay back in late nights, 2 to 4, up to 4 o'clock in the night. He used to study. Okay, I never used to study beyond 8:30 or 9 o'clock. And mine is getting up at 4 o'clock, like a farmer's son. Every now and then, every day almost, we used to get up at 4 o'clock. So that was my hobby. Even today, I do that. By 8:30, I sleep. But at the same time, Ravindra Reddy has a knack of using late hours. Maybe 6 o'clock or 7 o'clock, he eats and he starts his study, and nobody disturbs him up to 4 o'clock in the night. So everybody has their own competitive spirit. Nobody taught us. We got it. And we have used. Being in the same room, we used to follow different philosophies of study. Okay, so that's what I want to inform you. All these requirements must be there for any candidate to get into today's industry. And career by educational level. Okay, if you stop at a intermediate or ITI, you can become admin assistant in admin assistant. Okay, so what is admin assistant? There will be a foundry, there is a hot shop, and there is a welding shop. So many different shops of manufacturing. Okay, there he will be counting all the jobs, and he will be taking jobs when moving here and there with the help of all the tractors and trailers and all those things. And he will count at the end of the day. He will log books, maintenance, and all those things. Okay, day-to-day management and maintenance of that laboratories. It's called admin assistant. And if you stop at BSc or for engineers at diploma, you will become a technical assistant. Means you yourself will not be able to do any technical job, but you will be able to do the job assigned by a scientist. The scientist who will design a job, decides a job, and the job will be given to you. So you will finish that job by evening and go to home. And morning 9 to evening 5. So that is your time where you will perform all these technical activities under the guidance of scientists, and you will forget at the end of the day. But when you go to MSc, MPhil, PhD with GATE and CSIR, UGC, NET, and SLET, okay, state level eligibility test, and all those things we used to take number of times. Okay, then you will have a chance to become a scientist. And yesterday or day before yesterday, Honorable Prime Minister has told, there is no business for the government to do business. Okay, doing business is not government's business. So he wants to outsource each and every aspect. He wants to privatize each and every aspect of what government has been doing in various industries. Why? To improve the performance, to attract talent manpower, to abolish and remove the structure of reservation and the structure of what is that, some kind of nasty kind of culture, some kind of lazy kind of atmosphere he wants to abolish. And he wants to nurture the talent. He wants to stop the brain drain from India to abroad, equal opportunities to talented people. So for that, if you want to go to that level where you decide the scientific this one, you have to do MSc followed by MPhil or PhD, or you have to write GATE and score, and followed by CSR, UGC, NET, and you can go to different doctoral program. So you can become a scientist or a teacher. Teacher doesn't mean that primary school teacher. You can become a junior college lecturer or degree college lecturer, a university assistant professor, associate professor, professor, and all. Okay. So sciences education is for research. So please mind, if you take European Union and America, there is no BTech, there is no MTech. They recognize our BTech and MTech. What is BTech and MTech? It is only knowledge practitioners. The already existing knowledge is there, developed by scientists, developed by people of science. They practice and produce lot of designs and lot of items to sell in the market. That's what is BTech and MTech will do. Then what is the job of sciences? Like for example, in US, it is BS and MS, not BTech and MTech. Why is it so? They believe in scientific development, not technology development. Technology automatically it comes. The offshoot of science is technology. So the science education here is for research. So one needs to further his or her education till doctoral degree to get the research, to get into research field, or teaching or researching in an elite lab or university or an organization like DRDO or ISRO or Department of Atomic Energy. So one needs to go through the channel like BSc, MSc, MPhil or MTech, PhD, postdoctoral fellowship, research associate or assistant professor and so on, associate professor and full professor kind of thing. So this is all the hierarchical structures where you can envisage, if you want to envisage as yourself as a scientist in any of these laboratories where scientific work happens, you have to go through all these channels. And some useful tips for all the boys and girls who are online this evening. The maths is a must for all science students, including chemistry and biology. You know, lot of data analysis, lot of simulations, lot of interpretation, inherent in what is that called, inference is drawn using mathematical tools, even in biology, botany and zoology. So everybody needs, if you are a science guy, even arts, you need mathematics. Mathematics is inevitable. Knowledge of computers is desirable, if not a must. Identify your weak areas and overcome them. And you know, we keep going for DRDO interviews. Do I have another 10 to 15 minutes, sir?
Yes, sir.
Yes, sir, please.
Thank you. So when we go for DRDO interviews to different organizations, we'll ask, our first question is, why should I give you a job? And most of the children, they are afraid, sir, actually, sir, this, that, sir, I have to get job, sir. So they'll not be able to answer. Why? Because they are not prepared in that direction. Now, what for they need job? So it is their weakness that they will not be able to express themselves. So language is not a bar. Even in Telugu, they will not be able to tell. So the problem is they will not be able to explain and say that, sir, I am a fresher. You ask me anything in modern physics, I will be able to explain you. You ask me anything about heat, magnetism, light, optics, sound, or you name any subject, electrodynamics, electromagnetics. You ask me, I'll be able to explain. They will not be able to say that. If they say, they got a job. Any of them. It may be any subject. And another important thing is, we have to identify our weaknesses and overcome them. And we should bank on our strengths. Everybody will have some talent. So you are the right person to identify your own talent. You may be very good in mathematics, but you chose physics. So physics is entirely, 90% of physics is mathematics. So use your strength, mathematical strength in physics, and you can excel. In chemistry, almost 50 to 60% of chemistry is mathematics. Use your strength of maths in chemistry, strength of chemistry in physics, strength of physics in chemistry. You can use interdisciplinary nature of your strength. So overcome your weaknesses, improve, and bank on your strengths. Means Stand on your strengths. You learn more when you teach and explain others. Don't try to keep knowledge and data and related things for yourself. You try to disseminate. You know, after joining DRDO in the year 2003, early 2003, I have been making a lot of presentations. And this presentation, I have spent a lot of hours, but I give it to all the students. They will go and they will search, okay, related to all the topics what I have covered. If they may want to learn something more, they can use this. So I have been giving hundreds of my presentations, hundreds of my books, hundreds of articles I have been collecting to all the students, whoever is to whom it is useful. Okay, so the more you teach, the more you explain, the more you share, your knowledge will enrich. And these days, because of socio-geographic, socio-economic, social conditions, people are studying, means boys and girls are studying alone. It's not advised to study alone. Okay, you have a group, a common thinking group, and do combined studies. It gives a lot of advantage. So many concepts. I got clarity just because I have Ravindra Reddy besides me. And he doesn't know. He was clarifying my doubts. But whenever he studies in his own way and he solves all the problems in mathematics and physics, okay, I used to learn just because I have been there. I used to watch. I used to observe how he is solving, how he is studying, so just by being there as his roommate, it's me who got plenty of benefit out of it. Okay, and choose a subject in early BSc to do in MSc. Okay, if you wish to continue your education, you choose a subject of your favorite subject and keep on collecting so much data, keep on writing and enriching your notebooks, notes, and books. So all those things, you keep it with you so that it will be very useful during your MSc days or MPhil days or MTech days or PhD days. Don't lose any data. You know, in the year 2001 or 2, I have been making some notes. That notes even today I refer. So your own notes referring is a cherishing event for you, and also it gives lot of refreshment of your subject. And there are some study tips I want to give you. There is some concept called hook a book. So keep book as your companion. Okay, don't throw the book, read and throw the book. Don't do that. Keep a book whenever you are going somewhere, and put a book in your bag and just open sometimes and keep reading. So it will inculcate a reading hobby inside you, and reading hobby will give you a lot of motivation towards reading other books, related books, or you will seek additional information. Then immediately you will refer internet, refer library, refer original books which are written by great authors like Feynman, like Milliman and Halkias, like Resnick and Holiday. There are so many series, like MIT series, for example. We used to read all this during our MSc days and MPhil days. So read at random. This lot of scientists, what they have studied is, if you are alone and reading something, and your mind will go somewhere. Okay, after half an hour, you will be reading the same first sentence, or you are starting with great enthusiasm. You know, in our childhood, Ravindra and we used to make, because our sister, he used to stitch machine. Okay, she used to use stitch machine. Okay, we used to stitch a lot of ribbons, and every day we used to cut ribbon to start reading that day. From today onwards, we'll read a lot. Okay, then again we'll sleep. So many times we used to celebrate our reading, but somehow we'll sleep and forget it. So read at random. Don't be fully alone and keep reading. Okay, this I have also practiced sometime during my GATE preparation, MTech days and all. For example, go to Mayuri Center, okay, or go to a bus stand or some place where a lot of randomness. All people will be roaming here and there. So open your book and start reading. Okay, you will get full concentration. I'm telling you, all the boys and girls, please try this. So I think my email ID I'll post you after some time. You can give me feedback on that, because I have been taking all the engineering students' feedback for years, and it has been fantastically working for them. And I am sure that it will work for you also. Read at random. Okay, there will be huge noise and a lot of chaos around you, and nothing will disturb you, and you will be reading fantastically and gaining knowledge and all. I mean, your concentration will be perfect, rather than reading alone and falling asleep, and after some time you lose and your mind will go somewhere, and you have to write or make a phone call to your father to send money. That kind of things will keep on coming into your brain. So read at random is one of the useful things. Read original books. The third point is read original books rather than guides and notes. Okay, you make plenty of guides and notes, but read original books like Resnick and Holiday kind of books, so that the original thought process of the scientists you will come to know, rather than refined information. So note making patterns. Okay, we have been practicing. I don't want to inform you much about that. And visit research labs and get motivated. Please do visit. For example, the other day we thought we'll visit to a milk packeting place, where milk will come and packet will go there, and it will packet, and packet will be sealed, and sealed packet will automatically get into tray, and tray will be loaded into a container, and container will go into a lorry or something like that. Okay, it's a process. And we have visited some factories nearby, and you can come to DRDL, because of pandemic we are not allowing any students, but maybe I would like to come to SRN Bijanar College and invite all your faculty along with students to visit DRDO Hyderabad. We have plenty of facilities where you can see all the real-time science and engineering and technology being practiced here. So so when it comes to job sector, so of course forget about agriculture, and manufacturing caters for 11% of jobs, and also the education and government will provide another 4% of jobs, like 15%. So you always shall try to be within this 15%, so that your life will be more technical than a routine job. Okay, and I would like to come back at the end of my presentation to the DRDO logo and DRDL logo, where these feeble letters here, you see them in a bigger sense, that is Balasya Moolam Vijnana. The knowledge is power. That means the literal meaning of this is the source of strength is science. Okay, be proud of a science student, being a science student, and your science will be the source of strength for the enrichment of people's life on this planet. Thank you very much.
Thank you so much, sir, for giving a valuable and useful information speech. It is very motivational speech to our SR and BGNR college students. We are very happy being a alumni of our college. At the stage of scientist, you reached at the top level of the cadre. So we are very happy regarding your profession, sir. So ఈ అకేషన్ లో మీ నుంచి మేము ఒకటి కోరుకుంటున్నాము. పిల్లలకి చక్కటి ఇన్ఫర్మేషన్ ఇచ్చినటువంటి మీరు మన కళాశాల స్టూడెంట్ గా అక్కడ డిఆర్డిఎస్సిలో పనిచేస్తున్నారు కాబట్టి ఒక ఎంఓయు మీతోనే ఏర్పడు భవిష్యత్తులో చాలా ప్రోగ్రామ్స్ ని కండక్ట్ చేయాలని ప్లాన్ చేసుకుంటున్నాం. సో సైన్స్ అసోసియేషన్ మన కళాశాల తరపున మరి మీతోటి ఎంఓయుని ఏర్పాటు చేసుకోవడం కోసం ఇష్టపడుతున్నాం సార్, మీరు అంగీకరిస్తే. ఓకే సార్, థ్యాంక్ యూ సో మచ్.
మై కాలేజ్,
మరి
అవర్ కాలేజ్.
ఎస్ సార్. సో ఒక ఎస్ఆర్ఎన్ బీజీఎన్ఆర్ కళాశాల స్టూడెంట్ గా మీరు ఆ స్థానంకి ఎదిగిండ్రు అంటేనే చాలా సంతోషిస్తున్నాను. నేను కూడా మరి 88, 92 వరకు ఇక్కడ ఎస్ఆర్ఎన్ బీజీఎన్ఆర్ లో చదివిన స్టూడెంట్ నే. మై నేమ్ ఇస్ శాంతి కుమార్ సార్. మరి నాకు కూడా చాలా హ్యాపీగా ఉంది. కాబట్టి ఈ యొక్క ప్రోగ్రామ్ ని మీ ద్వారా డిజైన్ చేయడానికి ప్లాన్ చేసినటువంటి మా యొక్క టీమ్ మెషర్ చేస్తున్నాను. ఒక మంచి రూమ్మేట్ ని మీరు కలిగి ఉన్నందుకు చాలా హ్యాపీగా ఫీల్ అవుతున్నాను సార్ రవీందర్ రెడ్డి సార్. మరి ఆ స్థాయికి ఎదిగినటువంటి డాక్టర్ మల్లు వెంకటరెడ్డి గారి యొక్క సహాయ సహకారాలని మనం ఫ్యూచర్ లో తీసుకుందామని చెప్పేసి అని కోరుకుంటూ, మరి ఈనాటి సెషన్ కి సంబంధించి ఓట్ ఆఫ్ థ్యాంక్స్ కన్వే చేయవలసిందిగా శ్రీమతి పి అనురాధ మేడం, అసిస్టెంట్ ప్రొఫెసర్ ఆఫ్ సారీ సార్ సారీ మరి ఎనీ డౌట్స్ స్టూడెంట్స్ కానీ లేదా ఫ్యాకల్టీ కానీ అడగొచ్చు. ఇది క్వశ్చనర్ సెషన్. ప్లీజ్ ఆస్క్ ఎనీబడి ఎనీ డౌట్స్, ఎనీ క్వశ్చన్స్.
I'm sorry, I have taken one more. Actually, it is a 2-hour session because I have exceeded my time by 1 hour. So it is very difficult for them to stay online. But I think many students are there. It was students are there. If anybody wants to post me a doubt or something like that, they can approach Ravinder at any point in time. And if anybody wants to visit DRDL, so the right time.
Sir.
Venkat, thank you, Venkat, for joining us. You reminded all things who met earlier at our childhood and at the time of education.
Yes,
you reminded all these things, and
I remember that.
Those
actually
things
I remember
will help all the students and all the students community. Okay, thank you, sir. Shantikumar sir, carry on.
Okay sir. Okay sir. ఓకే, ప్రిన్సిపల్ సార్ మాట్లాడుతుంటున్నారు, మాట్లాడండి సార్.
సార్ రియల్లీ ఇన్స్పైరింగ్ బయటకు వెళ్ళి 3 years నేర్పింది. అది తర్వాత ఫ్యూచర్ లో దాన్ని ఎట్లా మేము ఆలోచిస్తున్నాం అనే దాన్ని మాట్లాడారు. తర్వాత ఫెంటాస్టిక్ అప్రోచ్. నేను అది చెప్పకుండా ఉండలేకపోతున్నాను. యాక్చువల్ గా ఒక సైన్స్ స్టూడెంట్ ఇప్పుడున్న పరిస్థితుల్లో ఫ్యూచర్ లో అసలు ఏ ఏజెన్సీస్ ఎట్లా పనిచేస్తున్నాయి, వాటిలో ఎట్లాంటి ఆపర్చునిటీస్ ఉంటాయి, ఇట్లా డొమైన్స్ ఏముంటాయి, వాటిలో ఇంట్రెస్టింగ్ ఒకవేళ మనకు అనిపిస్తే మనం దాంట్లోకి ఎట్లా అప్రోచ్ అవ్వచ్చు, తర్వాత డిగ్రీ ఫస్ట్ ఇయర్ నుంచే మనం ఎలా దాని మీద వర్క్ చేయాలి అనే దాని మీద ఎక్స్ట్రాడినరీ మీరు టాపిక్ డెలివరీ చేశారు సార్. నిజంగా నేను చాలా హ్యాపీ ఫీల్ అవుతున్నాను. అనుభవాలు కూడా సార్, రవీంద్ర రెడ్డి సార్ తో మీరు ఉండి రూమ్ మేట్ గా ఉండి, అంటే ఐ మీన్ అసలు అంటే స్కై ఈజ్ లిమిట్ అంతే. ఎవరికి కూడా నిజంగా ఒక పిల్లవాడు ఒకవేళ ఇవాళ నిజంగా మీరు ఆఫ్లైన్ మా కాలేజ్కి వచ్చి ఉంటే, ఇప్పుడు మా కాలేజ్ లో ప్రిమిసెస్ లో మా పిల్లలు ఇదంతా ఎంత ఇన్స్పిరేషన్ తీసుకునే వాళ్ళు అంటే ఇప్పుడు యాక్చువల్ గా మనం ఇప్పుడు వీళ్ళకి నిరుత్సాహం ఉంటుంది. అంతా కూడా ఒక ట్రెండ్, ఒక బ్రాండ్ అంతా ఇంజనీరింగ్. ఒక ఇంజనీర్ ఎవరు, ఒక సైంటిస్ట్ ఎవరు, ఒక ఇంజనీర్ ఎవరు, తర్వాత ఇదంతా ఎట్లా బయటకు వస్తుంది అనే దాని మీద మీరు మాట్లాడిన విధానం కానీ, ద ఫెంటాస్టిక్ అప్రోచ్ యూ డెలివర్డ్ బిఫోర్ అస్ సార్. నిజంగా అది మా పిల్లలకి కూడా, ఇప్పుడు వాళ్ళకి యాక్చువల్ గా 100 మంది పిల్లలే ఉన్నారు, కానీ ఇది 4000 మంది పిల్లలు ఉన్న కాలేజ్. ఇప్పుడు మీరు మాటలు విన్న తర్వాత 100% మాకేమనిపిస్తుందంటే, మీలాంటి వాళ్ళు కాలేజ్ విజిట్ చేస్తే దీంట్లో నుంచి ఈ 4000 మంది పిల్లలు 40 మంది పిల్లలు ఇన్స్పైర్ అయినా కూడా నిజంగా ఈ ప్రాంతానికి సేవ చేసినట్టుగా మేము భావిస్తాం సార్. మా సార్ కోరినట్టుగా మీతో ఒక MOU, అంతేకాకుండా మేము భవిష్యత్తులో మీకు డిఆర్డిఐ విజిట్ చేయడానికి మా పిల్లలు అంటే రవీంద్ర రెడ్డి గారు డెఫినెట్ గా ప్లాన్ చేస్తారు. దాంతో మీ దగ్గర నుంచి మాకు యాక్సెంట్ తర్వాత ఇంకా మేమేం కోరుకుంటున్నామంటే సార్ డెఫినెట్ గా భవిష్యత్తులో అంటే మనం అంటే చదువుకున్న కళాశాలలకి నుంచి వచ్చే మీ జూనియర్స్ అంతా కూడా, ఈ పిల్లలంతా ఎవరు అంటే మీ జూనియర్స్, ఈ కాలేజ్ చదువుకునే పిల్లలంతా కూడా, వీళ్ళందరికీ కరెక్ట్ గా మీరు ఒక మీలాంటి పెద్దలంతా కూడా మంచి డైరెక్షన్స్ ఇచ్చి ఈ కళాశాల చేస్తున్న సేవలో ముఖ్య భూమికలు పోషిస్తారని మేము ఆకాంక్షిస్తూ మరొకసారి మీరు ఇచ్చిన ఒక అద్భుతమైన ఉపన్యాసానికి మళ్ళొకసారి చేతులు జోడించి నమస్కారాలు తెలియజేస్తూ సార్ నేను సెలవు తీసుకుంటాను. థ్యాంక్ యూ సార్. థ్యాంక్ యూ వెరీ మచ్.
థ్యాంక్ యూ వెరీ మచ్ సార్.
సార్ థ్యాంక్ యూ సార్. థ్యాంక్ యూ సో మచ్ ప్రిన్సిపల్ సార్. సో ఈనాటి ఈ సెషన్ ని ముగించే ముందు ఓట్ ఆఫ్ థ్యాంక్స్ ని అందజేయవలసిందిగా శ్రీమతి అనురాధ మేడం, అసిస్టెంట్ ప్రొఫెసర్ ఆఫ్ మ్యాథమెటిక్స్ అండ్ ఆల్సో సైన్స్ అసోసియేషన్ member. Please continue, madam.
Okay, sir. Good evening, everyone. Respected Principal Sir, Sri K.S.S. Ratnaprasad Garu, and today's Chief Guest, Sri Mallu Venkat Reddy Garu, Vice Principal, Sri T. Jeevan Kumar Sir, IQAC Coordinator, Srimati Anjani Madam, and all faculty members and all the participants. I wish you a happy National Science Day. On behalf of Science Association, in association with IQAC of the SR and BGNR Government Degree College, I, P. Anuradha, Assistant Professor of Mathematics. 1 minute, sir. Assistant Professor of Mathematics, feel privileged to propose vote of thanks for today's national webinar on science and technology in Indian strategic sectors, career prospects for science students. I pay my lot gratitude to our beloved Principal Sri K.S.S. Ratnaprasad Sir. You always been a backbone of every activity of our college. It is not possible to conduct these webinars without your support, sir. And also extend my gratitude to our Vice Principal Sri T. Jeevan Kumar Sir, Head Department of Physics, for extending his support to conduct this webinar successfully. Sir, you always fill our minds with your enthusiastic and motivational words. And I am very elated to talk about our resource person, Sri Mallu Venkat Reddy Sir, scientist, DRDO, Hyderabad. Really, we came to know many new things about science and technology. You explained very briefly, very elaborately on DRDO, about DRDO and DRDL, and the extra inspection of missile system, mathematical reconstruction. And you told one important point that maths is the central point of every field. Thank you, sir. Yeah. I am an admirer of your perseverance and will to extend cooperation in empowering the government sectors. Really, we received a high information about you, your lecture, sir. Thank you so much. Sir, you are not only a scientist, but also a motivation speaker and career counselor. And our students are very lucky to hear your speech, sir. And your students never forget your guidance. Thank you so much for supporting us, and really it's a great opportunity for us. And also thank you, sir, for accepting MOU with our college along with we also. Thank you so much, sir, supporting us and participating with us today. And I also thank Srimati Anjani Sursetti, Coordinator IQAC and Head Department of English of this college. Ma'am, you are quite wonderful. Not only this particular webinar, you are the supporter for every webinar continuously conducted in our college. And always admire your wonderful cooperation and patience. Thank you, ma'am. And I thank you, our Science Association convener, Dr. V. Santkumar Sir, Associate Professor of Chemistry, for organizing this excellent webinar in such a manner that this webinar is very useful for both the faculty and students in their future career. Thank you, sir. And also extend my thanks to our HOD of Hindi, Attota Samsura sir, for a wonderful cooperation and your technical abilities. And also thank for the members of Association, Science Association, Dr. Ravindra Reddy sir and Dr. Surendra Reddy Garu, Dr. Ravi Shankar sir, Assistant Professor of Zoology. And also extend my thanks to all HODs of Science Department and all faculty members for making this Science Day a memorable one. Thank you, sir. Thank you so much.
థ్యాంక్ యూ వెరీ మచ్. ఈనాటి ఈ యొక్క వెబినార్ సెషన్ ఇంతటితో ముగిసినట్టుగా తెలియజేయటమైనది. మరి ఫీడ్బ్యాక్ ఫామ్ పెట్టడం జరిగింది. దయచేసి అందరూ కూడా ఫీడ్బ్యాక్ ఫామ్ ని కంప్లీట్ చేసి వెళ్ళవలసిందిగా కోరుతున్నాను. థ్యాంక్ యూ సో మచ్ వన్స్ అగైన్ సార్.
థ్యాంక్ యూ.
డాక్టర్ మల్లు వెంకటరెడ్డి గారు, మిమ్మల్ని పర్సనల్ గా కలుస్తాను సార్. థ్యాంక్ యూ సో మచ్ సార్.
థ్యాంక్ యూ ఆల్. థ్యాంక్ యూ మై డియర్ బ్రదర్ రవీందర్ రెడ్డి. థ్యాంక్ యూ.
థ్యాంక్ యూ సార్. థ్యాంక్ యూ సో మచ్.
థ్యాంక్ యూ వెంకట్. థ్యాంక్ యూ.
ఓకే సార్, కంగ్రాచులేషన్స్. థ్యాంక్ యూ సార్. అవును సార్, మీరు ముందు బయట మీరు బయట బయటకు వచ్చినా మీరు మాట్లాడితే పడుతుంది.
నేను బయటకు వచ్చిందే ఏం కాలేదు, తప్పే మాట్లాడలేదు కదా, ఏం కాదు. కానీ చాలా చాలా మంచి ఇన్ఫర్మేటివ్ ఉంది, ఎక్సైటింగ్ ఉంది. పిల్లలు మాత్రం చాలా బాగా మీకు హార్టీ కంగ్రాచులేషన్. దీన్ని థింక్ చేసింది మాత్రం మీరే, చేయాలి అనేటువంటిది ఒక ఆలోచన. అన్నా నెక్స్ట్ టైం మీరు ఒక సైంటిస్ట్ ని పట్టుకొద్దాం ఉన్నారు కదా, నెక్స్ట్ టైం అది కూడా ప్లాన్ చేద్దాం డెఫినెట్ గా.
నేను ఏమంటాను,
ఓ మరి ఇంకేం సార్, మరి ఇంతమందిని పెట్టుకోవాలి మనం సార్. మ్యాథ్స్ అన్నిటికీ మూలం అని చెప్పేసి అని చెప్తున్నాడు సార్.
నేను ఒకటి చెప్తాను చెప్పండి. ఏంటంటే ఇప్పుడు కాలేజ్ లో ఉన్న ఒక 60 మంది కరెక్ట్ గా సీరియస్ థింక్ చేసి వాళ్ళ ఫ్రెండ్ సర్కిల్ ఎక్కడెక్కడ హైయర్ డిపార్ట్మెంట్ తో సెట్ అయి ఉన్నారు, ఎట్లా సెటిల్ ఉన్నారు చూసి వాళ్ళ లిస్ట్ తీసుకొని మనము ప్లాన్ చేసి ఎప్పుడు ఏ అవసరంతో ఎవరితో ఉపయోగించుకుంటూ పోతే మనకు చాలా మంచిది ఉంటుంది.
తప్పకుండా సార్. ఇప్పుడు సరే ఓకే, యాజ్ ఏ సైన్స్ అసోసియేషన్ కన్వీనర్ గా ఎవరెవరితో ఏ లింక్స్ ఉన్నాయో మీరు నాకు ఇస్తే నేను మొత్తం వాటిని సమప్ చేసి వాళ్ళ మెయిల్ ఐడీస్ ప్లస్ ఫోన్ నెంబర్స్ తో అడ్రస్ తో సహా మొత్తం ఒకటి తయారు చేసి పెడతా. దానివల్ల కాలేజీలో అది ఉంచితే ఎవరికైనా ఉపయోగపడచ్చు. ఈ రోజు మనం ఉండొచ్చు, రేపు ఇంకొక వాళ్ళు ఉండొచ్చు. డేటాబేస్ తప్పకుండా చేద్దాం. అది మాట్లాడండి సార్, మాట్లాడండి, ఒక ప్రోగ్రామ్ ఫిక్స్ చేద్దాం.
హైదరాబాద్ వచ్చాడు, హైదరాబాద్ లో కొత్తది పోలీస్ రాడార్ సిస్టమ్ పెట్టాడు కదా, ఇన్ఛార్జికి వచ్చాడు.
ఓకే ఓకే,
రాత్రి మాట్లాడతాం
తప్పకుండా
అరేంజ్ చేద్దాం.
తప్పకుండా, చాలా చాలా.
రాడార్ సిస్టమ్ ఒకటి.
కానీ మన స్టూడెంట్ అయ్యి ఉండి ఈ స్థాయికి ఎదిగినటువంటి వాళ్ళు ఎంత ఎక్సలెంట్ గా చెప్పండి, మామూలుగా లేదు. అయితే సార్ మేమైతే మీరు ఎట్ట చదువుతారో ఏమో మాకు తెలియదు, కానీ మీ ఫ్రెండ్ ద్వారా మాత్రం మీరు 4 గంటల దాకా కూడా నిద్రపోకుండా చదువుతారు నైట్ అని చెప్పేసి అని తెలుసుకోగలిగినాం. సో మీ రహస్యం ఇదే, మీ రహస్యం బయటపెట్టండి సార్. సక్సెస్ రేట్
4ంటికి 5ంటికల్లా లేస్తాడు.
అదేలే,
మేమే 2 దాకా 3 దాకా చదువుకొని మేము పడుకుంటాం. అది కంఫర్టబుల్,
ఇది కంఫర్టబుల్. అదే
వాడు 8ంటికి పోతాడు సార్,
చెప్పాడు కదా ఇప్పటికి కూడా అదేంట. అదేనట
11, 12ంటికి మొదలు పెట్టి వస్తారు, 4-5ంటికి చదువుతాం పడుకుంటాం. అలాగే ఇప్పుడు పుస్తకం
ఓకే.
గ్రూప్ 1కి అంత ప్రిపేర్ కాలేదు సార్.
అదే
ఒక్క సంవత్సరం అమెరికన్ కంపెనీకి డైరెక్టర్ బెంగళూరులో ఉన్నాడు. ఆయన కూడా మా ఎలక్ట్రానిక్స్
నేనే రెడీ.
ఈ ఫైల్ గ్రూప్ లో పెట్టినా, దీంట్లో పెట్టినది పెట్టలేగా
పెట్టిండుగా ఇప్పుడు
పెట్టింది సార్. మీరు దీంట్లో పెట్టిండే గూగుల్ మీట్ లో పెట్టిండు, ఇన్బాక్స్ లో పెట్టిండు. ఎగ్జిట్ అయితే ఉండదు,
ఎగ్జిట్ అయినా కాబట్టి
ఉండదు. అంతే కదా సార్, మళ్ళీ గ్రూప్ లో పెట్టచ్చు.
లేదు, ఎగ్జిట్ కాలే.
ఇప్పుడు ఇన్బాక్స్
ఫీడ్బ్యాక్ ఇవ్వ ఇక్కడ నుంచి
కొట్టండి.
ఓకే.
మా బ్రదర్ ఏం చేసేవాడు, రోడ్ అనుకున్నాడు. రోజు అనుకుని పెద్ద రిపేర్ చేసుకొని పని చేసేవాడు. 10 నిమిషాలు యాక్టివ్ చేసుకోవాలి. రిపేర్ కట్ చేయాలంటే చదువు రిపేర్ కట్ ఊరుతున్నాడు. స్టార్టింగ్ మోటివేషన్ ఈ రోజు మోటివేషన్ ఈ రోజు స్టార్ట్ చేద్దాం, ఈ రోజు స్టార్ట్ చేద్దాం. పోయి జన సమాధానం అక్కడ అవ్వమంటండి.